This isn't just about breaking machines down. It's about how engineering evolves, how materials are reborn, and how even legends return to the factory floor. Welcome to Factory Founder in Folien, where massive machines, extreme engineering, and industrial mega projects come to life.
In the quiet light of early morning, long shadows stretch across an industrial landscape the size of a small city. Towering cranes stand still against the horizon. Conveyor systems rest silently. And beyond the gates of this vast open recycling complex lies a sight almost unimaginable. Hundreds of aging, rusted B-2 Spirit stealth bombers awaiting their final transformation. Once symbols of advanced aerospace engineering and strategic air power, these aircraft now sit weathered and worn. Their once matte black stealth coating has peeled and cracked. Aluminum skins show streaks of oxidation. Composite structures are exposed, frayed by time and the elements. The aircraft that once seemed almost futuristic now resemble relics of another era. The process begins long before the first bolt is removed. Transport convoys deliver retired aircraft to the facility under controlled logistical
The primary
operations.
crack extends from the cockpit edge down to the radar panel.
Measuring.
Under bright industrial lighting and natural daylight streaming through overhead panels, technicians begin the careful work of component removal. Landing gear assemblies are detached first. Hydraulic lines are depressurized. Corroded steel struts are unbolted. Massive crane arms support the weight as teams remove each assembly in a synchronized sequence. Next comes the cockpit canopy. The once advanced flight deck, now silent and aged, is methodically separated from the fuselage.
Signatures are within spec. Cross-check the routing on channel 3. Looks good, let's secure it now.
Check the wiring on circuit board 4. Copy that, adjusting now. Needs to be secured firmly, don't rush it. All right, we're loose on this side. Checked. Engaging the lift mechanism now. Slow and steady, looks good.
The glass shows microfractures. The surrounding frame reveals oxidation beneath chipped coatings. Avionics modules follow. Wiring harnesses, brittle with age, are disconnected and categorized. Circuit boards are removed for electronic material recovery.
Secure the line on the fuselage. Flow engaged, watching the levels. Reading stable at the nose. Okay, engage the main hoist now. Clear. Bring it down slowly. Check the hydraulic lines on the left. Verified, lowering now. Keep it steady, watch the pressure. Yeah, I'm watching. Just a little higher, easy.
Engaging lift.
Copy. Adjusting clearance.
Watch the leading edge.
Clear there.
Engines are extracted using reinforced lifting rigs. Turbine housings display heat discoloration. Fasteners require careful handling due to corrosion. Each engine is placed on a reinforced transport cradle for separate processing. Fuel tanks are drained and removed.
The pumps are running smoothly. Keep an eye on the pressure. Copy that. Monitoring the flow now. Keep it steady. Looks like it's almost full. Okay, watch for overflow.
Verify the hydraulic pressure on station 3.
Readings look good. We're initiating the drain.
All right, let's get this secured. Careful with the weight. Needs more banding right here.
The aircraft slowly transitions from a recognizable form into a skeletal industrial framework. With systems removed, the aircraft moves into structural segmentation. This is where scale becomes undeniable. The wings of the B-2 are expansive, sweeping outward in a blended flying wing configuration. Hydraulic cutters are positioned along structural joints. Plasma torches are prepared at reinforced spar intersections. At command, cutting begins. Sparks cascade downward as corroded titanium spars are separated from the fuselage core. Composite skins, once engineered for stealth performance, are sliced into manageable panels.
Line up the lift. Engage the plasma torch now. Clear the area, watch for sparks. Water jets on. Keep it steady now, just a little more to go. Looks good, maintain pressure. Copy that, retracting now. Line it up slowly. Roger that, bringing it down. Check the connection point, almost there. Clear to connect. Keep it steady, watching that tail. Lowering, lower, almost there, watch your fingers. Looks good, let's secure it. Move the trolley closer.
Ensure the alignment is perfect on the next pass.
We're calibrating now.
Watch for heat buildup on the outer layer.
Keep the angle steady. You need to detach the strut now. Copy that. Proceeding with the cut.
Okay, ready to cut.
Engaging hydraulic shears.
Sparks are flying. Watch your distance.
Lifting the fuselage now. Stand clear of the cables. Hold the position. Set it down slowly, guys. Clear, coming down. Almost there. Keep it steady. Got it. Moving on to the rivets. I've got this section loosened. Okay, I'll disconnect the main harness here. Careful with the red one. Just a little more pressure. Keep it steady. Guide it down slowly.
Almost there. Mind the edges.
Looks aligned. Ready to secure.
This lagt ingen bin den sagt da der kultur auf Ibrien da so in der Zeka gakli das produce task what
Tanks 7 and 8 are good to go. Yeah, yo, copy that. Moving to 9 now. Status inside is clear.
Next comes the phase that transforms structure into raw potential. Massive industrial shredders, some the size of multi-story buildings, await the segmented components. A crane lowers the first fuselage section toward the shredder's intake.
Keep it steady. Guide the nose. Lower just a little more. Engage jaws. Clear the area.
Rotating blades, forged from hardened alloys, begin to turn. As the corroded aluminum meets the teeth of the machine, the structure yields. Panels buckle, internal ribs fracture, composite skins tear apart into fragments. The noise is immense, yet controlled. Wing spars are fed into secondary shredders designed for high-strength metals. From the shredders, thousands of fragments travel along a network of conveyor belts stretching across the facility floor. Metal shards clatter forward under bright daylight streaming through skylights. Titanium pieces reflect flashes of silver. Black composite fibers tumble alongside oxidized aluminum fragments. The conveyors split into multiple channels. Magnetic separators lift ferrous metals upward, depositing them into collection bins. Non-ferrous metals continue onward. Engine housings are reduced in specialized crushing chambers. Within minutes, what once formed the aerodynamic body of a stealth aircraft becomes a cascade of fragments moving onto conveyor belts. Dust suppression systems activate.
Keep the aisle clear. Affirmative. Forklift approaching from the south. Crane is lowering.
Keep it moving over there. Careful with the weight. Check the levels. Transferring to bin 90. The stress fracture is right here. Okay, I've got this one sorted.
Once sorted, materials enter secondary refinement. Aluminum fragments are washed to remove surface contaminants. They pass through crushing mills that standardize size for melting. Titanium pieces are separated into high-grade and mixed-grade streams. Each is catalogued for resale or remanufacturing. Fibers are reclaimed for industrial reuse applications. Electronic components are sent to specialized recovery lines where precious metals are extracted. Throughout this stage, laboratory teams conduct quality testing. Samples are analyzed for purity, tensile properties, and alloy composition.
Initiating compression. Ensure the tolerance is within specs.
The robot is recalibrating the scan.
Move that assembly to Station 3.
What began as a single aircraft now exists as multiple refined material streams, each ready for reintegration into the industrial supply chain. Recycling a complex aerospace platform requires environmental vigilance. Fluid residues are neutralized and processed through treatment systems.
Line it up. Good. A little lower. Perfect. Look solid. Nice work, team. Let's get the next one. Keep sorting those. Grab the titanium ones. Watch your hands on the jagged edges. Pallet 12A needs to go in Bay 4. Copy. Pallet 12A to Bay 4. Scanning bale 187, all clear. Lower it slowly. Watch the heat. Okay, moving it down. Clear the area, please.
The mold is almost full.
Keep it steady. Keep it steady. Lifting now.
Keep the furnaces hot. Overhead crane is moving into position. Keep it steady. Watch the alignment. Maintain the speed. The thickness is good. Crane, lower the hook. We're ready.
The oxidation levels are within spec. Running the final contour pass now.
Setting the tolerance to 0.05.
Confirming 05. Initializing cycle.
Main arm engaged. Monitoring pressure.
As refined materials accumulate, they are packaged for dispatch. Aluminum billets are stacked on reinforced pallets. Titanium scrap is secured in sealed containers.
Slowly.
Composite granules are loaded into industrial sacks. Each pallet receives barcode labeling and documentation. Supervisors verify shipment logs against inventory databases. Tablets and handheld scanners replace clipboards, ensuring digital accuracy. Forklifts move in coordinated patterns, loading transport trucks under daylight supervision. The yard, once filled with broken aircraft, now contains neat rows of material ready for a new purpose.
Okay, down slowly, watch the straps. Move it in. That's it, perfectly aligned. Ready to place this one. The measurements are consistent with the specs. Let's double check the finish over here. That's the correct batch. Confirmed. Let's move to the next aisle. Keep it steady. Straight back. Copy that.
One by one,
Moving slow.
transport trucks roll towards the exit gates. Drivers receive clearance from dispatch coordinators. Final inspection tags are confirmed. As the trucks depart, they carry with them the future materials that may become architectural structures, automotive components, industrial equipment, or perhaps even parts of new aerospace platforms. Nothing is wasted. The recycling yard gradually clears. The cranes stand idle once more. The conveyors slow to a stop.